In this lab exercise, you're taking a book class, creating a series of book objects, storing them in a collection of some sort, in this case an array list, and then calling upon the sort algorithm in the collections class to sort them. But here's the issue. The book class consists of a number of different fields. So you can see here that there's title, author, publisher, pages, ISBN, and price. So any one of those fields could be a legitimate way of determining the sort order, and we want the flexibility to be able to sort them in whatever order we want. Let me come over to the actual code in Eclipse. So I'm flipping over. And you can see the very first call to do sorting is nice and sweet and clean. There are no errors. The second call, oh, there's that red squiggle underneath, an indicator, and of course the big red X, an indicator that there is an error. Well, that's intentional because this is the work you have to do. You have to create a completed comparator to deal with the author, another one to deal with the ISBN, another to deal with the price, and if I slide down a little further, another to deal with the pages. So here's the issue. We want to be able to call the sort method inside the collections class. Now, I've mentioned before, naming conventions are very important. You can see here it's capital C collections. That tells you it's a class name. Because it's a class name, it means I'm calling upon this method labeled sort without actually using an object. That means that that particular method, sort, must have been defined inside the collections class as a static method. Static methods are ones that can be called without having an object. Well, that's great. It allows me to do the sorting I need to do without having to worry about creating an object for that. Now, the sort algorithm that was created inside the collections class is a very good quality algorithm, very high performance. But the problem is the creator of that particular class a number of years ago had no idea that it was going to be sorting books. So in a sense, we have to teach this algorithm about the nature of the data. Two things we have to teach it. One, where is the collection of books or the list of books that is to be sorted? Secondly, how are we going to compare two book objects to see if one is bigger than the other? And this is where we have to decide, are we comparing based on price, author, title, pages, ISBN number, etc. So, first part's obvious. First part's easy. The argument that I'm sending here is a reference to the collection that's going to store the books. Well, notice when I double-clicked on list books there, that all of the other uses of list books are highlighted. This is the original declaration of the variable list books. So, list books is a reference to a list that can contain book objects. Now, what may look a little unusual over here, notice what I'm actually going to be assigning into this variable list books. My intent is to assign a reference to a newly created array list. Now, the syntax may look a little odd in the sense that the data type here is a little different than that, but in fact, this is very normal. This is, in fact, the best way of doing this kind of organization. To check that out, let's actually go to the Java documentation for list and see what we can find. So I'm going to flip over to the documentation I've already loaded up. This is the Java Standard Edition 7. I'm going to look up list, so come on down. And when I get down to list, you can see that there are actually a couple of different flavors of list. The key difference is, oh, that's in italics. Italics tells you that it is an interface. This is in bold, and it also tells me in the little pop-up that this is in the class Java AW, or the class is in the Java AWT package. AWT for Abstract windowing toolkit. Well, I'm not dealing with windowing stuff. This is the one that I do want. So when I click on that, you can see that, yes, list is an interface. And you can note that all of the known implementing classes, there they are there. The most important one of which is what I'm working with today, the array list. So here's the rule. You can create a reference to variable, as I'm doing over here. So list books is a reference to variable. Its data type is reference to list, which can store book objects. That's what the angle brackets are all about. So this is going to be a reference to a list object, but then I have the option of either making an array list or an attribute list or a linked list or a role list or a stack or a vector and so on. I'm choosing to make an array list. But it means later on, if I really wanted to, I could change this and say, well, I'd like to experiment with doing it with a linked list. And it would work. Now, the only reason it's complaining here is because it doesn't have the import. If I was to import, then that would go away. This program would work much as before, slightly different performance, but essentially it would work the same as before using a linked list. This is really a sweet characteristic of interfaces. List is the overriding interface. I can create a reference to variable to an interface. Now with interfaces, because the interface is fully abstract, I cannot do this. I will get an error. And this error I can't get rid of. Notice the error says it cannot instantiate type list. Well, that's correct, because list is an interface, and interfaces are the most abstract of organizing structures. It's like a super abstract class. So you can't make an implementation of a list, but I can make an implementation of any of these known implementing classes. The first two I can't because they're also abstract, even though they're classes. But I can do it for all of the other ones that are in that collection there. So let me come back. I'll put it back to array list, which is what it was originally. There. So I'm making an array list, going through a process of adding a series of books to that collection. And by the time I get down here then, and this was the line of code I was talking about a moment ago, list books will be a reference to the array list. And that satisfies what the sort method is expecting in collections. Let's go look that up. So I'm going to come back over to the Java API. This time I'm going to go and look for collection with the S. Just need to find it. And notice that this is not in italics. It's regular type. So that tells you it's a class. Yes, collections with an S is a class. And it has exclusively static methods that operate on collections. Well, I have ArrayList. ArrayList is a kind of collection class. And one of the static methods that I want, and let me jump down to the method summary by clicking here, and I'm looking for sort. It's alphabetized, so I need to slide down a little. Two different flavors of sort. This one only takes one argument, the list to be sorted. This one takes two arguments, the list to be sorted and what's called the specified comparator. Let's go take a look at the details of this method by clicking on it. This jumps me in the Java API documentation to the more detailed description. So the second argument that's coming in is going to be a reference to a comparator object. All right. That's what this is going to be over here. This then is a fulfillment of that expectation sort is expecting to receive a reference to a comparator object. So what's a comparator? Well, let's go look it up. Comparator. Get the right spelling. There it is there. Notice comparator is in italics, so we know that it's an interface. Comparator interface. One of the things that I've said before about interfaces, an interface enforces a contract. The contract is the methods that you must implement if you're going to be using or implementing this interface. Let's take a look at the method listing. So I'll click on method here, jumps me down. There are two methods that are expressed inside the comparator interface. One of them is compare, the other one is equals. We'll come back to this in a moment, but let's now go back to the program code. Here I am here. And if I take a look at compare title, which does work, I did implement that. I'm going to go to the declaration of that. Here it is. So this little bit of code does work correctly. The code below, well, these are places where you have to take a look at the pattern, see if you understand the pattern that's there, and then implement your own versions of these other comparators. Let's ignore these ones with the red X's at the moment. Let's focus on the one that is completed correctly. So, I am going to implement the comparator interface. So, here we are back at the comparator interface documentation. Contract. The contract says I must implement the methods that are in the interface. So I'm implementing comparator. I must implement the methods. Oh, and there's compare. So I am, in fact, choosing to implement the compare method. And there it is there. Let's jump down to the detailed documentation, and in fact it's right below, so I can just slide on down. So the compare method is expecting to receive two arguments, and the two arguments, well, what's this T? This is all part of the world of generics in Java. I'm going to slide all the way back up to the top of the comparator documentation. And notice, inside these angle brackets, angle bracket, T angle bracket, there's nothing particularly special about the fact that they've chosen the letter T. It could have been anything. This is a placeholder. This is kind of like a variable data type. So I can put into the angle brackets any data type I want. And you'll notice, when I go back to the Java code, I have put book as the data type that I'm mapping onto comparator. That means the comparator class that I'm inventing is going to be dealing with book objects. So the book that you see here really corresponds to the T you see here. Now if I come back down to the compare method, there's the T. So you don't actually type in T. No, you substitute for the T whatever data type you want to work with. So back over to the Java code. I'm choosing to work with book. That means that when I implement the compare method, well, I'm going to be dealing with a couple of book objects. When I receive them, I can just do the natural comparison. They're strings, and so I can call upon the string compare to facility. For greater clarity, let's walk through a process where I actually fill in that. I'm going to delete the highlighted code here. I know that I'm dealing with book 1 and book 2, so I can go after book 1. I now have a reference to a book object, which came in as an argument here. Of course, it's just a number, remember, because all reference to values come in as just numbers. This would be a location information of a book. I'm going to type the dot operator. that spawns a list of all of the things that are available for a book. And because I'm doing a comparison on the title, well, I can go after the title. There it is there. Now, what can I do with a title object? Well, this is a reference to a string. And so when I hit the dot operator, this shows me everything that's available for a string object, and I want to do compare to. What am I comparing it to? Well, I'm going to compare it to the title in the other book. So book 2 dot title, and I'm done. How do I know that I'm done? Well, take a look at the documentation here associated with the compare to method for string. Let me just slide it open a bit more so that you can see it fully. Notice the return value here. When the compare to method inside the string class is finished, it's going to return a value that's less than 0 if the first string is less than the second, or a value greater than 0 if the first string is greater than the second, or the value 0 if they're equal to each other. So that's what the compare to is going to do, and that matches the contractual requirement of the compare method. So let me come on back to the compare method. Remember, we were talking about this. This is what you have to invent for your comparator. And the contract requires a negative integer 0 or positive as a way of signaling whether something is less than, equal to, or greater than. And so this fulfills the requirement for compare. Now, I don't know if some of you noticed back over here, I'm back into the Comparator documentation. We've just finished talking about the compare method, but the contract says you must implement all of these named methods. So yeah, I did implement compare. There, you can see it there. There is my implementation of the compare method. Equals? I didn't implement equals. How come I was able to get away with that? Well, that's because every class that you ever create inherits from object. Now let's go find object over here. Object is the mother of all classes. So there is object, and there are already a handful of predefined methods inside object. There's equals. So I didn't actually have to implement equals, I could have, as a fulfillment of the comparator contract. But you'll notice that inside here there is no instance of a compare method. So I was required to implement my compare method here. One of the questions then that may come up is, well, why do we have to do all of this? Well, here's the reason. When you come back to textbook, the act of doing a sort on a list of books, now in this case I've only got, about a dozen, but imagine that I had millions of books. The act of sorting, when you're dealing with millions of items, means comparing a couple of books again and again and again and again and again. You can well imagine that with millions of books in a list, that the compare method would be called probably hundreds of millions of times, again and again and again. So what you're doing here is, you're not actually intending to call the compare method right here. No. What you're doing is telling the sort algorithm, where is the compare method? Because internally the sort algorithm is going to have to call that compare method again and again and again. You're not calling it directly. The sort algorithm is going to call it indirectly. And so what you really want to do here is send the address of a method, the address of a function, so that the algorithm can get access to it somewhere in memory, because it is in memory. But here's the issue. You cannot send a real address in Java. It's just not allowed. It's a way of protecting you from yourself so you don't make the kind of spectacular bugs that you can in a language like C. Oh, you could get away with sending a raw address to a function or a method in C, but you cannot in Java. The only thing you can ever send is a reference to an object, reference to an object, reference to an object. That's all. You cannot send the actual address of the method. So here's what we're doing. Back over in book, we're going to send a reference to an object that contains the compare method. So I'm going to say this a couple of times because you may not catch it the first time. Here I go. I'm creating a class called CompareTitle. Remember, a class specification doesn't actually create an object. It just expresses the potential to create an object. So I'm creating class CompareTitle, but I do need to make an object. There it is there. I'm going to make a new CompareTitle object and capture its location in this variable. So instance is a reference to a variable containing the location information for this new CompareTitle object. That's what I'm sending in. Notice? I'm using the CompareTitle class name and sending the instance in. So this entire expression is going to allow me to send the reference to an object, in this particular case the comparator object, that contains the compare method to compare two titles of two books. Now some of you may be wondering, well, why do you have all of these extra dots in here? Well, it's because I chose to bury the CompareTitle method inside the book class. I didn't have to do it this way, but I think it's better style. You'll notice then that the act of creating this CompareTitle class is prepended with the modifier static. All that means is that this particular class isn't really dependent upon its parent. I'm inside the book class, right? That's where I'm here, book.java. I could have extracted all of this code, cut it out of here, and put it as a top-level class in its own little file, and it would have been saved as CompareTitle.java. I would have had to delete that, but other than that, it would be identical. But here's the problem, or not problem, but the reason that I don't want to separate it is this particular comparator class here, it only has meaning or significance for the book class because I'm actually acting on internal instance fields inside book, the title. And then later on I want to do it for the author and pages and ISBN and so on. So I wanted to put these standalone classes inside the book class just to keep it more neatly organized. It also means that I can get direct access to an instance field like title, even though it is, let me slide on up to the top, even though it is private. Good stuff. All right. One last thing. I want to make sure that this is this particular class I'm building here is a singleton pattern. That means there can only ever be a single instance of a CompareTitle compare title object created. The way I do that, notice here, the constructor for compare title is private. That means no one can ever create a compare title object outside the boundaries of this tiny little class. Great. That ensures that it's just a singleton. Secondly, the first time anyone calls upon this variable instance in order to get an instance, it will create the first and only instance of the object. And because it is final, this setting of the instance variable can't be done a second or a third or a fourth or a fifth time. Once it's established once, it's fixed. And that guarantees that I will have one and only one instance of that. So, that's the essence of the task or the challenge that you face. You then have to get these other ones working. The pattern is very similar, where you're going to be creating a comparator class to deal with author, to deal with ISBN, to deal with price. And the compare operation, or the compare methods, are going to have to deal with slightly different things because the data types are different. I have strings for those two. I got a long integer. Here I've got a double. And here I've got just an int. So there will be slight variations on the way that you handle a compare method for each of those. So that's the essence of your challenge. Once you've done that, you'll be ready to implement the merge sort algorithm, which is part of your next activity.